Hi everyone, welcome back to the video. In this video, we are going to discuss the past paper question number 8 in this particular series. Let's get into this. It is a trigonometry based question, both right angled and non-right angled involved. Also like sector and the part of circle is also included in this. So let's get into this. A diagram is given. Clearly it is given to us a sector of a circle. Inside that, a circle is inscribed in it, right? The sector is ABC and it is a sector of a circle with center A, and the angle at BAC is 2 alpha, where alpha is between 0 to pi by 2, and OEA is equal to exactly pi by 2. Even if this OEA is not given, we know the fact, right? It will be pi by 2, the point of contact and the radius there will make 90 degree. And a circle with another circle with center O, whose radiuses are is inscribed in the sector. AB and AC are both tangent to the circle D and D respectively. This diagram is not to scale, and we have to prove the first part as area of quadrilateral ADOE is R square by tan alpha. Right, let's get started with this. So first, quadrilateral, let me connect it. This is the center O and its radius is R, it is given. Let me connect O1D. Since AB is a tangent, the radius and tangent at the point of contact will make a 90 degree. So it's 90, this is also 90. We got a quadrilateral. This quadrilateral is special. It is nothing but kite. Right? Why I'm telling kite? This is R, this is R. Length of the tangents from an external point are equal. So EA and AD, they are equal. When adjacent sides are equal, it is a kite. So we can directly use the properties of kite also to solve the terms like angles and sides. Okay, coming back to this. To simplify it, let me draw a angle bisector at A. So because quadrilateral, I'm going to break into two triangles. And yeah, if you draw a triangle, if you draw a diagonal for a quadrilateral, and this is the longest diagonal, this will split into two congruent triangles over here. So I got two triangles, triangle AEO and triangle ADO makes the quadrilateral. The triangle, okay, actually it's a quadrilateral. Quadrilateral ADOE. Okay, so we got this. And okay, both are right triangles, so it's very simple and they are congruent. These are congruent triangles. So finding area of one triangle is enough. So triangle of ADOE is twice the area of the triangle. Let me take AOE triangle. Okay, at E it is 90, O and A. What is OE? It's radius. What is AE? I don't know. So let it be. And we know the property, the angle will be, these are congruent, right? So 2 alpha will split into alpha and alpha. This is 90 and 90, so this will overlap, right? So they will bisect into two equal parts. And angle at A of this particular part is alpha. Now, area of a triangle is, area of triangle AOE is, or AEO anyways, equals half into base into height. Let me take the base as OE times, this is a basic formula, and AE. So half into what is OE, it's R, times what is AE, I don't know, but let's frame this. I know the alpha, in terms of alpha only we have to represent, right? So to include the OE and AE, which is, that is hypotenuse is not included, so we will always go with tan alpha. So using right angle trigonometry, tan alpha is nothing but opposite over adjacent. Opposite is this one, R. Adjacent is AE. Now I want expression for AE. So AE is R by tan alpha. Right? So half into. So this is what we got. AE we can replace R by tan alpha. Now we got R square by 2 tan alpha. This is area of the triangle AEU. But what is the area of quadrilateral, right? So let's do here. area of quadrilateral is twice, because we split that quadrilateral into two congruent parts, and 2 times r square by 2 tan alpha. 2 will get cancelled. We got r square by tan alpha. Hence, it is a proof related one. We have proved this part, right? And that's simple. Now getting into the next part. The same picture, a part of the region is shaded. That is, we can see the shaded part that is named as region R. Okay. Right. So find, this is the same figure and a part of the region is shaded, which is marked as R. And find DOE in terms of alpha, right? So first, that is the central angle they're asking for. Let me connect. We want particularly this angle. It's quite easy. In a quadrilateral, sum of angles will equal to 360. But this question is revolving around the radian measure. So let's go with radians equal to 360 is just nothing but 2 pi. So I know this is 90, this is 90, which is pi by 2 plus pi by 2 plus this is 2 alpha plus my angle DOE equal to pi. Pi by 2 and pi by 2, it's pi. So DOE will be 2 pi is there, and this pi will shift over there minus pi. 2 alpha will shift over 2 alpha. So totally it's pi minus 2 alpha. So angle DOE in terms of alpha is this. Right? And that's simple first part. Now next part, hence or otherwise find an expression for R. So what is the area of the shaded region? R is region shaded here, and let's go. Area of the R. Right, so area of R, how can we define? From this quadrilateral, if you remove this sector area, you will get the shaded portion. So area of the quadrilateral we already derived. So just find area of the sector and remove it. So what we have analyzed now, area of the shaded region. Area of R is equal to area of quadrilateral ADOE minus area of the sector. What is the sector name? It's DOE. Let it be. Right. And area of a quadrilateral we know. Now to find area of the sector. And what is area of sector formula? It is available in the formula booklet. Let me share the screen with you now. So this is the area of the sector formula. Right? In radian form it is. If it is in the radian form, we can use it. And we're going to take this one. Right? So it's half theta r square. Half r square theta. And let's switch into the solution page now. Okay. So half r square. R square, R means what? Radius of the sector. So what is radius of the sector? It's R, right? So r square only. And theta. Theta is the angle, the central angle. That's DOE. Just now we find it. It's pi minus 2 alpha. That's it. And if you can simplify, you can. So now we have area of a quadrilateral. So now area of R, let's conclude it here. Area of R is, quadrilateral area is r square by tan alpha minus, this can be written as r square by 2 pi minus 2 alpha. That's it. This is the expression for area of the shaded part. Hope it is clear. Right? And that's simple. Now moving into the next part. Find the value of R for which area of R is equal to area of the circle with center O and radius R. Okay, area of R, we found it just now. And in which, for which value of R, the area of the shaded region R and the area of the inscribed circle will be equal. Okay. Area of circle with center R, center 0 O and radius R is nothing but pi R square. Right? So area of R, you equate with area of circle. Circle with center O and radius R. Okay. Now area of R is, it's quite big term. Let me copy. R square by tan alpha minus R square by 2 pi minus 2 alpha equal area of circle with center O1. This is basic formula, pi R square, right? And we have to look for which value of alpha actually it is, for which value of alpha, right? First thing, I will take R square common, simplifying, right? You need to make alpha as a subject. Minus pi minus 2 alpha by 2 equal pi R square. R square will get cancelled. And focusing on alpha. Okay, actually we can go with the solving for alpha using the numerical solver. Equals pi. So let's switch to the GDC and solve this part. Here we go. So in the home, go for calculate and menu, go for algebra, numerical solve. We have one variable, right? And type in the equation. We got first a fraction. 1 divided by 8. 1 divided by tan alpha is there. So tan alpha, let me name it as x here, minus, okay, that is again a fraction. There pi minus 2 alpha. That is alpha is x here divided by 2 equals, we have pi again on the right side. That's it. And what we are solving for? We are solving for x here. And let's just click enter. We got 0.218 and it is in radius form, right? So that's it. We can finalize our answer here. And switching into the solution page now. So using the technology, we have solved this. Right. So my x is 0.219 radians, not in degrees. And okay, actually in the problem, in this context, it's alpha. So the best way. Alpha is equal to 0.219. And this completes the problem. In this problem, from the start till the end, we have come through the investigation, like step by step. So that's simple. And thank you so much for listening. Let's meet in the next series.